Okay, just for fun, for physics students, I'm going to derive the general case. Okay, so my function of time is now capital A for any constant number times t to the n power. Okay, so we're going to do the limit. I like little s. My small something is going to approach 0, and now my function is a times t plus s to the n power minus just a. Whoops, that's terrible handwriting. What am I doing? You know, in college I learned to read and write Japanese for some reason, for fun, I think. And so I start to write Japanese characters once in a while. That's what's really happening. Anyway, and then we have t plus s minus s on the bottom. Holy smokes. So, what I would have to do, this is why I skipped it for your first run through. I just used an example that we treat in physics a lot, acceleration due to gravity and stuff. I'm going to have to binomial expand t plus s to the n power. And off the top of my head, because I also don't sleep enough, I can't remember exactly how to expand that. Let's see if I can do it. Well, we're going to binomial expand that term, and we subtract a times t to the n power. But then we divide it by s. Whoops, this was plus t, minus t, excuse me, for delta t. We just divide it by s as s approaches 0. Okay, let's see if I can remember enough of it. I'll learn more if I try it. So we'll have capital A, and we gotta binomial expand. I factored out my capital A. Well, it's gonna start t to the n power, and then it's t to the n minus 1 power times s. And then it's got coefficients. I know there's a 1 for the first coefficient. What's that next coefficient? Oh, math. As a sleazy mathematician, I'm going to put coefficient n minus 1. Ha 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 ha. I don't have to know what it is. Times s, and then we do plus coefficient of n minus 2, t to the n minus 2, and then times s squared, and then x plus dot 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 dot. Okay, there's a ton of them. It goes until I run out of n's. It goes until I have n minus n. So I'd have to keep writing and writing and writing. If it was 100 power, it was like 100 terms. Okay, see if I can jog my memory. I still have my minus a to the n to write on the end of there, and I'm still dividing by s. What is that coefficient? That binomial expansion coefficient. Is someone at you waving at me because you know what it is? Because you're a super genius? Why aren't you teaching this class? Not old enough. Good excuse. No, you like they'll pay me more as a math professor at Purdue. Haha, Whitcomb. You're wasting your time and money. Maybe I am. No. Sure, what is it? It's 1 and then just n? I think you're right. It's n because if I had 2, I would FOIL and I would get an n. If I had 3, I would triple FOIL and I'd get a 3. It's n. And then this next one is n times n minus 1, isn't it? And we start building like this factorial thing. N times n minus 1 times n minus 2 times n minus 3. Yeah. Genius. Okay, all the numbers multiplied back. Wonderful. What happens to this first term? Oh, subtract it out. 0. I don't even get to divide it by s. Okay, I got a limit. S approaches 0. what terms do I actually keep? Okay, so now I've got an n times t to the n minus 1 times s. And I've got the first factorial term, n times n minus 1, t to the n minus 2, no, wait, yes, n minus 2, s squared, and then there's a ton more. But I cancel those, and then I divide by s. But what happens? There's one s to cancel there, so I didn't even have to do the limit. And then everywhere here, there's at least one extra s. And as I do more and more factorial powers, n minus 2, n minus 3, n minus 4, now there's extra s's left over. Well, I certainly can multiply by 0 repeatedly. It's just as easy as multiplying by 0 once. Oh no! I bumped the board. Technology. So I don't even really have to do this limit. All I have to say is f prime, that I did all that mess, I would still have my capital A, forgot it, equals the n power times the capital A times t to the n minus 1. Just like I told you at first. And you didn't want to believe me. Ta-da. For monomials and polynomials, it always works. I honestly will tell you, we're going to have to grip sine and cosine and some of those other ones, check the equation sheet. But they're not that hard either. I'm not going to make you do the limits of sine and cosine. I have a better trick. Okay, but if you see this nonsense in your calculus class, you might think that Wickham turned down a job at Purdue calculus physics teaching and somehow came here. Whatever. I just love my students so much. But I know some shortcuts and tricks. And they're trying to make you do it the hard way. So you learn and you get confused and then clear up the confusion. It's good teaching techniques. But if you're stuck on calculus, I know all the shortcuts.